Chapter 6, Section 6.1, the Law of Sines. In this section and the next one, the Law of Cosines, we will be working on solving triangles that are not right triangles. The types of triangles that we will be solving are oblique triangles. An oblique triangle is a triangle that does not contain a right angle. An oblique triangle has either 3 acute angles or 2 acute angles and 1 obtuse. The relationship among the sides and the angles of right triangles defined by the trig functions are not valid for these triangles. So we can't use SOHCAHTOA on these triangles or the Pythagorean theorem. We're going to have to use law of sines and then in the next section, law of cosines. Here's our definition for law of sines. Capital A, B, and C are all angle measures. And then lowercase a, b, and c are all sides, opposite of those angles. We have side A divided by sine of angle A is equal to side B divided by sine of angle B, which is also equal to side C divided by sine of C. So we're not going to use all 3 of these ratios. We're just going to pick the 2 that we want to use. So first of all, if we want to solve for side A, we're obviously going to use side A over sine of A. And then if we know both of our C's, for example, then we would just set these 2 equal and not worry about using B at all. Anytime the directions say to solve the triangle, this means we're going to find all of the side lengths and all of the angle measures. So we're solving for every part. Law of sines can only be used on triangles that we know the side angle angle, so SAA, or that we know angle side angle, ASA. Example 1, solving a side angle triangle using the law of sines. So we're going to solve this triangle where angle A is 64 degrees, angle C is 82 degrees, and side C is 14 centimeters. So I'm going to expect you to be drawing these triangles as we go. I think this is the only problem that I have in the notes where I already have it drawn. From now on, I will be drawing it right along with you. But really quick, let's make a big note. If you set this triangle up wrong, then your problem won't work out. So notice that angle C is across the triangle from side C. Angle A is across the triangle from side A. And same thing with B and B. Okay, so we're going to round our lengths to the nearest tenth at the end. So first of all, it's always important to figure out what we know both of. I know both big C and little c in this problem, so that's going to be important. I know little a, so the only thing I can find to begin with is, I know big A. The only thing I can find to begin with is going to be little a. We would have to know one of our b's in order to solve for a b. We don't know either of them, so we're going to start by solving for little a. So I am always going to put my unknown first. So whatever I'm solving for is going to go first. So little a over sine of big A and little c over sine of big C. So this is the setup that I'm going to use since I know both my C's and one of my A's. So plug in everything that we know. And then to solve for little a, I need to move sine of 64 to the other side of the equation. I'm going to do that by multiplying since it's attached by division. Now, I haven't even touched my calculator yet. Okay, don't be putting parts of this in your calculator as you go. Get a completely alone and then plug it in your calculator. We get a equals 12.7. If you plugged this into your calculator and you didn't get 12.7, make sure you ask your teacher. Your calculator could be in radians instead of degrees, and so it could be a setting that we need to change on your calculator. Okay, so I went ahead and labeled side A as 12.7. Next, we're going to find angle B. That's going to be pretty easy because we already know 2 of the angles in our triangle. If we just take 180 minus 64 minus 82, we get angle B to be 34 degrees. The last part that we have left to solve for is side B. So I'm going to have side B divided by sine of B equals side C divided by sine of C. Multiply over sine of 34, and we get B equals 7.9. So the three answers that we need for this problem are side A equals 12.7, angle B equals 34 degrees, and side B equals 7.9. Example 2, solving an angle-side-angle triangle using law of sines. So this time we don't have the triangle given to us. We're going to have to draw it. So we know that angle A is 40, angle C is 22.5, and side B is 12. Okay, so when drawing our triangle, I always put C at the top. You could really put it anywhere in the triangle. I would encourage you to do the same as me just so that our triangles look the same though. So we've got angle A on the bottom left, angle B on the bottom right, and I have labeled little a and little c. The first thing I'm going to solve for is angle B. The reason I'm going with angle B first is because I don't know both of anything. So I don't know both of my A's, I don't know both of my B's, I don't know both my C's. But I know I can find angle B pretty easily by doing 180 minus 22.5 minus 40. Now that I know both of my B's, I can solve for either little a or little c. Let's start by finding little a. And I'm using both of my B's for the right ratio. Then when we put this in the calculator, we get little a equals 8.7. Next, we're going to solve for side C. Remember, we can't just use the Pythagorean theorem here because it's not a right triangle. So I'm going to need to use law of sines again. So side C over sine of angle C. And again, I'm using B's for the right side. So we get side C equals 6.1.